In this video lecture, we shall see the CMOS design style. Okay. Now that we are familiar with writing the schematic diagram or the circuit diagram for CMOS, the next step is to write the stick diagram. Okay. And in the last video lecture, we have also seen the NMOS as well as the CMOS encoding being used. Okay. So a theory question may also be asked. Once it was asked, discuss the CMOS design style with a diagram. Okay. So in CMOS, the layers which are involved are N diffusion, so we represent it by green color, P diffusion, which is represented by yellow color, polysilicon represented by red color, metal by blue color, and contacts by black color. Okay. So before you start writing the stick diagram, you should be familiar with the encodings. Okay, so you should study those encodings properly. Okay, so the first step in the design using the CMOS design style is the rails and the demarcation line. Okay, first is draw the metal, that is VDD and VSS rails in parallel. Okay, so this is what is done here. So this is VDD, this is VSS. Okay, and then he says keep enough space. So there should be enough space between VDD and VSS for other circuit elements, that is the transistors and wires connection, to be represented here. Okay, you should have enough space. So it depends upon the Boolean equation you are going to implement. Next, you have to draw the demarcation line. This is the demarcation line. Okay, so this NMOS and PMOS circuitry are separated by this demarcation line. Fine. So this is step number 1. Second, you have to form N and P transistors. Okay, so we have seen in the stick diagram rules that whenever a poly crosses a diffusion, it forms a transistor. Okay, so NMOS transistor is formed when a poly crosses the N diffusion type. Okay, and PMOS transistor is formed when poly crosses the P diffusion. Okay, the NMOS circuit is arranged in a pull down network between the output and the low voltage rail. Okay, so and the PMOS circuit is arranged in a pull up network between the output and the high voltage rail. Okay, so if you see this is your NMOS, which is arranged below this demarcation line. Okay, and all the NMOS circuitry which comes below this demarcation line, it is connected between the low output voltage rail VSS and the output. And if you see this NMOS, you have this green color which represents N type diffusion. Okay, and a poly is crossing this. Okay, and this forms one NMOS transistor. Okay, similarly, a PMOS circuit is arranged above the demarcation line. As you can see, P diffusion, it is represented by yellow color, and a poly has crossed, so which makes it as a transistor. So this is PMOS. Okay. The third step is connection is done as per the CMOS circuit. Okay, in this we have taken a simple example of CMOS inverter. Okay, now there are some rules which you have to remember. Diffusion paths must not cross the demarcation line. Fine, what does it mean? So whatever the diffusion you have written, this yellow color, okay, this is the P diffusion, this should be always above this demarcation line. It should not cross this demarcation line. Similarly, this N diffusion, which is represented by green color, this also should be below this demarcation line. This should not cross this demarcation line. That's the first point. And N diffusion and P diffusion you cannot join directly. Okay. So to join the N and P type features, you have to use the metal. Okay. Can you see here? So this is your P diffusion. This is your N diffusion. So both are joined by a metal, blue color. And you see a contact is been established here. Fine. So to join N and P type, you have to use a metal. Okay. Metal and polysilicon can cross the demarcation line. Okay. As you can see, poly is also crossing the demarcation line and metal is also crossing the demarcation line. Okay. Crosses should be placed on VDD and VSS rails to represent the substrate and the P-well connection. Okay. So you have to place cross, one for the substrate connection and other for the P-well connection. So here the CMOS inverter which is in discussion is of P-well process. Okay. So you have to go back to module 1 to see CMOS fabrication using P-well process. Okay. So these are the 3 steps which includes the CMOS design style. Okay. Now the example I have taken here is of a simple CMOS inverter. Okay. So this is the CMOS inverter schematic which you have already seen. See VDD represented by blue color, VSS represented by blue color. Then the next step is drawing the demarcation line. Then form a transistor. So you have one PMOS. So we formed one PMOS transistor. We have one NMOS. We have formed one NMOS transistor. Okay. The source is connected to VDD. That's why this diffusion, P diffusion is extended and connected to VDD. And this is connected to ground. That's why the N diffusion is extended and connected to VSS. Okay. Gate is shorted. Okay. Gate is nothing but your polysilicon. Okay. That's why. So the polysilicon is shorted and the input is given. Similarly, the drains. Okay. As I have said earlier, you cannot join N diffusion and P type features directly. So I have used a metal and I have taken output as Vout. Okay. In some textbooks, the output is taken via polysilicon also. So in that case, since polysilicon will be a different layer, then you have to indicate a contact here. Okay. So this is about the CMOS design style. Okay. We shall solve more number of problems in this and also some assignments so that you are familiar with the CMOS design style. Thank you.